Welcome to ZoomInData. In this section, we explore DBT advanced production patterns and scalability, focusing on strategies to handle large data volumes, maintain reliable pipelines, and optimize performance in enterprise environments. You will learn about modular modeling, incremental processing, snapshots, macros, and scalable deployment practices. These concepts are crucial for production-ready DBT projects and are often discussed in interviews for advanced data engineering roles. Subscribe to ZoomInData for more structured DBT tutorials, real-time project insights, and interview-focused content. Let's dive in. What is scalability in DBT? Answer: Scalability in DBT refers to the ability of pipelines to handle increasing data volume or complexity without performance degradation. It ensures that as the organization grows, analytics pipelines remain efficient and reliable. Scalability involves optimizing models, materializations, and warehouse resources. Proper planning is key for long-term DBT success. Why are advanced production patterns important in DBT? Answer: Advanced patterns provide standardized approaches to building robust pipelines. They reduce errors, improve maintainability, and enhance performance. DBT encourages modular design, version control, and testing. Following these patterns ensures production readiness at scale. What is modular modeling in DBT? Answer: Modular modeling breaks complex transformations into smaller, reusable models. Each model performs a single logical operation. DBT models are then referenced via ref in downstream transformations. This improves maintainability and debugging. What is layering in DBT? Answer: Layering organizes models into stages like staging, intermediate, and marts. Staging models clean raw data. Intermediate models perform business logic. Marts provide final analytics-ready tables. Layering improves readability and scalability. What is the importance of standardized naming in DBT projects? Answer: Standardized naming ensures clarity across teams. DBT models, tests, and sources are easily identifiable. Reduces confusion and improves collaboration. Critical for large-scale projects. How does DBT handle incremental loading for scalability? Answer: Incremental models process only new or updated records. Reduces runtime and warehouse cost. Ensures pipelines scale efficiently with growing data. Incremental logic is implemented via unique keys and filters. What are macros in DBT and why are they useful? Answer: Macros are reusable SQL snippets or functions in DBT. They reduce repetitive code and enforce standard logic. Used for calculations, formatting, or dynamic queries. Essential for scalable, maintainable projects. Why is documentation important in advanced DBT patterns? Answer: Documentation clarifies model purpose, dependencies, and logic. DBT supports automated documentation from schema.yml files. Helps new team members understand pipelines quickly. Improves project maintainability at scale. How does DBT handle large datasets efficiently? Answer: DBT uses incremental models to process only changed data. Partitioning and clustering improve query performance. Materialization strategies are optimized for warehouse resources. Efficient data handling ensures smooth scaling. What is the role of testing in scalable DBT projects? Answer: Tests ensure data correctness as pipelines grow. DBT supports uniqueness, null, and relationship tests. Automated tests prevent errors from affecting downstream analytics, critical for maintaining reliability in large-scale deployments. How do macros contribute to DBT scalability? Answer: macros reduce repeated SQL logic. Changes in one macro reflect across multiple models. DBT ensures consistency in calculations and transformations, saves development time and improves maintainability. What is the benefit of DBT snapshots for production patterns? Answer: snapshots track historical changes in source data, useful for slowly changing dimensions. DBT maintains versioned data for auditing and analysis, enables reproducible analytics over time. How do DBT seeds support advanced patterns? Answer: seeds are static datasets loaded into the warehouse, used for reference tables, mappings, or default values. DBT integrates seeds into pipelines seamlessly, improves efficiency in transformations. How does dependency management improve scalability in DBT? Answer: dependencies are tracked via ref. DBT executes models in correct order, helps avoid errors due to missing upstream data, essential for large and complex projects. What is the role of model selectors in advanced DBT workflows? Answer: model selectors allow targeting specific models for execution. DBT supports tags, folders, or specific names, enables partial runs to save time and resources, improves operational efficiency. How does DBT support team collaboration in large projects? Answer: version control ensures all team members work on the same codebase. Modular design reduces conflicts. Documentation and macros enhance consistency. Collaboration scales as team size increases. How does DBT manage warehouse resources efficiently? Answer: incremental runs, optimized materializations, and selective execution reduce compute usage. DBT allows configuring targets and schemas for efficiency, avoids unnecessary data processing. Cost and performance are controlled in large-scale environments. How does DBT support multi-environment deployments for scalability? Answer: different targets, dev, test, prod, isolate workloads. DBT ensures changes are validated in safe environments. Rollbacks are possible if issues arise. Supports scalable and safe deployments across environments. How can advanced materializations improve DBT performance at scale? Answer: incremental, ephemeral, and table materializations balance performance and storage. DBT uses incremental for large datasets to minimize computation. Ephemeral models avoid unnecessary storage. Optimized materializations reduce runtime and cost. How does DBT enable reproducible analytics in production? Answer: version-controlled SQL and macros ensure reproducibility. Snapshots and seeds maintain historical and reference data. DBT pipelines produce consistent outputs, critical for auditing and compliance in enterprise environments. What are common challenges when scaling DBT projects? Answer: increasing data volume and model complexity. Dependency management across hundreds of models. Monitoring and alerting at scale. DBT best practices mitigate these challenges. How does DBT support incremental testing for large pipelines? Answer: tests can be applied selectively to models or incremental runs. DBT prevents retesting unchanged data unnecessarily. reduces runtime and resource consumption, ensures data quality at scale. How can macros and modular design reduce maintenance overhead? Answer: single changes in a macro propagate across all dependent models. Modular design isolates logic and reduces interdependencies. DBT ensures consistent behavior and faster updates, critical for scalable production pipelines. How does DBT support high-frequency production runs? Answer: incremental models allow frequent updates without full refresh. Efficient materializations and model selection reduce execution time. DBT integrates with orchestrators for automated schedules, enables near real-time analytics pipelines. Why is knowledge of advanced DBT production patterns important for interviews? Answer: demonstrates understanding of scalable, reliable pipelines, shows practical experience with large-scale deployments, highlights ability to optimize performance and cost. Strong answers reflect production-ready skills and differentiate candidates. Thank you for watching. Please subscribe and follow ZoomInData for more DBT tutorials and interview questions. If you want guidance on real-time DBT projects, contact ZoomInData. See you in the next video.